Hello everyone! In this video we will continue to examine topic 5.2, the heating effect of electric currents, and in particular we will examine non-ideal voltmeters. Now recall that our ideal ammeters and voltmeters were ammeters and voltmeters that managed to be wired into the circuit without affecting the properties of that circuit. Okay, and so our question is, what would the effective resistance of the instruments need to be to do that? Well, consider the voltmeter for a second. Imagine the voltmeter has some appreciable resistance in the ballpark of this R here. What happens? Well, if the voltmeter has sort of a small resistance, then it's going to reduce the effective resistance of this whole section of the circuit, right? It will, as a result, it will reduce the total resistance of the whole circuit, and it will reduce the potential drop actually across this resistor. So in order to not affect the circuit at all, we need the resistance of this voltmeter to basically allow no current to pass through it, and therefore not reduce the effective resistance of this piece at all. As a result, we need the resistance of our ideal voltmeter to be infinite. Okay? It's also worth noting that if the source is ideal, there's no reason not to do this. It's much safer if we have a very large resistance, and it requires no energy. Note that real voltmeters will have a very large but not infinite resistance, and what we need is for the resistance of the voltmeter to be sort of sufficiently big, that is sufficiently bigger than the resistance of this resistor. Usually you want a factor of 10, even more really. Why? Because you are going to decrease that equivalent resistance. And so you don't want to decrease that equivalent resistance and increase the current if you can help it. Consider the calculation of the current through the resistor, right? Measured by this ammeter, currently assumed to be real as well. So if the, currently assumed to be ideal as well. So if the EMF is then applied to R total, but R total is 1 over RR plus 1 over RV inverted, okay? And the resistance of the voltmeter is infinite. Notice that if it's infinite, this term drops out. But if it's not, you actually affect the current. The current is no longer just the EMF divided by R total. It's the EMF times this quantity, which is going to actually increase the current a little bit. So a real voltmeter can be thought to have this sort of small, sort of large, but not infinite resistance here. And so it will actually affect the current slightly. And you just need to be aware of it. Because real voltmeters are designed to have a very large but not infinite resistance, though, they are much harder to break in practice. And what you will find is that if you wire a voltmeter in like an ammeter, you will simply reduce the current in your circuit. So what will happen is, for example, if this is a lamp or a light bulb, that light bulb just won't turn on. If you wire an ammeter in parallel, so if you wire an ammeter inappropriately because they have a tiny resistance, you can actually destroy the ammeter. And this is probably the most common way to destroy the ammeter, is to wire it in parallel with the element that people are trying to measure. So just be aware of that.